Well, thanks everybody for coming to the Polymer talk. My name is Taylor. I'm the product manager on the Polymer team at Google. My esteemed colleague Alex just gave a great presentation on Service Worker, which is one of the big, exciting kind of new developments in the web platform that's coming through the pipeline. And I'm here to talk about kind of another one of these big, exciting new developments coming on the web platform, notably web components, and then the Polymer library that we're building on top of web components. So first, a little agenda, what I'll be going over today. First, I'll talk about the web component specs, what they actually entail, what they mean for you, what they look like, how the Polymer library itself kind of brings these web component specs together in something that's meaningful and that developers can use. And then finally, I'll kind of go into what this new world of web development might look like and the new powers that you get and the new powers the community gets with Polymer, with web components. So what problems are we solving? To kind of frame the discussion, this has kind of been touched on a lot, and I think will continue to be touched on, but web developers, web applications have really high expectations nowadays. Everybody has a browser in their pocket, and they expect their web applications to function just as well, if not better, than their native applications. They expect them to work across a million different types of devices and screen sizes and resolutions. They expect them to be 60 frames per second, smooth and silky to the touch, with responsive animations and nice transitions, work offline. And it's a really, really hard premise to build on the web, given that the kind of components that we're working with in DOM are mostly based on text markup, to be frank. You're getting headers, and you're getting lists, and you're getting paragraphs, and you're getting divs, whatever those are. And it's mostly built around kind of document markup. And so for today's web, it might not be the right set of tools. So I'll give an example. Building UI tabs should be really, really easy. It's such a common user interface element. Users expect to have tabs. It's a great way to navigate between frames and screens. Should be easy. It's not. There are a million different ways that different frameworks or different UI elements, components try to solve this problem on the web, and they're all different, and they're mostly incompatible. So you have one way, which is kind of scaffold this out in markup, and then have some magic JavaScript incantation that will set up your UI tabs for you. There are other ways, which is let me actually just kind of scaffold this all out directly in JavaScript, and then have my framework lay out the DOM, stamp the DOM incorrectly. And then there's kind of a smashing in between where I maybe put markup inside of a template, inside of a JavaScript, inside of a tag. And again, they're all incompatible. It should be easier than this. It shouldn't have to be this hard to build a set of UI tabs. So it's a big promise, and it's a big challenge. But I can give evidence that already we kind of have a lot of power in our toolkit. So I'll start out with the humble select element that you are probably familiar with. This has been in the web platform for decades. It's just the select tab. Really simple. You can use it to pick things, drop downs, things like that. So it's a little lonely, so we'll give it some children. So select elements have their children as options, and so you can lay out a set of options. And this alone is really, really cool. So all I did was I put a select tab in saying, hey, I want this dropdown, and then these are what the dropdown items are going to be. And the browser, the user agent, magically knows how to set this up for me. It knows to give me this button with the little arrows on the side. I didn't tell it to put those arrows there. I just knows to put them there. You click it, it brings out your menu. You got all your items laid out in there for you in the same order. You can click one, make that the selected one. You also get keyboard shortcuts, basically. You can open it, you can, with your spacebar, you can drop down with arrow keys, select with enter key or spacebar. You get all of this for free with a really, really simple markup. And there's more than that. So I can declaratively kind of change the style and behavior of this with attributes. It's really great. I can put it disabled on some of these. And again, the user agent will know how to render that correctly. It'll gray out the tag, and I won't be able to select it. And then I can get even more complicated. So I can put a select multiple on here, and it totally changes the UI. Now, instead of a single dropdown, I need to be able to select more than one. So I can kind of option select or command select, whatever it may be, more than one of these. I can put in op groups, another type of child that this select element understands. Organize these into op groups, give them labels. Again, it's all declarative. It's all totally readable. It's really the minimal amount of markup that you could possibly need to get really complex behavior. And then it only understands children of a certain type. So you can try to put a P in there. nothing will happen, it'll just ignore it. You won't get a breakage, it just kind of nothing will come out of it. And then finally, what you can't do in DOM declaratively, you can do in script. So it's got a script API that I can kind of poke and prod at and get its selected index. I can add event listeners, get change notifications, behave on the changes. It's a really cool element. It's a really cool set of principles that the element follows. It's declarative, it encapsulates its own behavior. It's reusable across context, so I can use it in a navigation menu. I can put it in a form, and then it's got a whole new meaning where it kind of sends data across the network when I submit a form. Super duper powerful. I want to make an element like this. I don't want to have to scaffold a whole bunch of divs to get my component to work right. I want to make an element that's just like the select button. So that was the kind of reasoning behind web components, is developers should be able to do that. You should be able to create your own components that have all of the powers that these really cool native widgets have, like select, and build arbitrarily complex elements that are totally encapsulated and totally reusable. So kind of the big theme with a lot of these new APIs is it's a total sea change, where instead of trying to kind of force feed new features onto developers where you have to use it in this one particular way, we're trying to take a step back and say, what if we just give the same primitives that kind of explain existing features of the platform directly to developers on their own, and that let you build the feature on top of it. So that's kind of the theme with service workers, and it's also the theme with web components. Let's give developers the primitives to create these awesome things using the web platform, and I think it's really ushering in a golden age of web development. So I'll get in more directly to the web components specs. Web components is kind of the umbrella term, and there are 4 specs that make up web components. The first is custom elements, so relatively straightforward. It's built into the platform. It lets you define new HTML and DOM elements. So we might recognize this. The div is overloaded. We know this. It makes it really hard to read output. With custom elements, now all of a sudden, we can actually create syntactic declarative elements. We can name them. We can register them with the platform, so you can use them just like any other element. So you can create declarative code, makes meaningful HTML come out, and then it gives you a common way also to extend native elements. So instead of just creating a totally new element, which you can do, you can also take an existing element, like an input, and extend it to give it new behavior. So that's a really cool part of this new custom element spec, too. And in addition to the declarative nature, you can also get all the imperative goodness. So you can query select for your custom element, just like you would any native HTML element. And then you can put event listeners on it, just like you would any native HTML element. So it's all the goodness of your HTML element plus whatever you might want to add to its behavior. So second is template spec. So template spec, also relatively straightforward. Spec writers saw, OK, all these different frameworks try to create some notion of a template. Why don't we bake that right into the platform? And that's what the template tag is. So new template tag lets you kind of write your markup as you would in HTML. Use DOM to scaffold DOM. It's logical. You're not trying to kind of shove it into a script tag to make it disappear or put a display none, which may or may not have side effects. It's parsed but not rendered. It's inert until you actually stamp it out on your page. And it's a document fragment. So it's kind of exactly how you'd expect a client-side template to behave, natively built into the platform. The third piece is shadow DOM, which is a little more subtle but incredibly important and a super cool feature. So shadow DOM gives you these kind of composition and scoping primitives that lets you build these little elements in a truly encapsulated way. So shadow DOM is not a new idea. So shadow DOM actually already exists, and browser vendors have been holding out on all of us, web developers. So if you put a video tag in, HTML5 video tag, this is actually laid out in markup. So I put a video tag, I put an end video tag, but I get this play button, I get a scrobbler, I get a time, and I get a mute button. Where did those all come from? And they're actually shadow DOM. So if you go in and you turn on shadow root user agent inspector, you can actually dig in and say, oh, well, this is just markup. It's a bunch of divs and then some inputs, and it's styled. None of that leaks out. My tree is scoped, so I can't accidentally poke and prod at it. But it's just markup, and it's hidden away from kind of user level behavior. So it's a really cool primitive, and it's pretty complicated, but it's great to use in practice. And then the final spec in web components is HTML imports. So this kind of ties it all together. How do you do dependency management? You need to be able to import things onto the page. So we're used to kind of this mode. This is what you need if you want to bring Bootstrap onto your page. You've got a couple of link rels and then a whole bunch of scripts, and one after the other. Shouldn't be this hard. HTML imports is just a new way of doing this dependency management with a link rel equals import, href equals Bootstrap, and then that can define its own dependencies. So instead of having to stamp everything up on your first page right away, you can define dependencies as kind of more modular way. So to review, we got custom elements, lets you create new HTML elements. Templates, which is native templating on the browser. Shadow DOM, which gives you really powerful scoping and composition. And then HTML imports, which ties it all together and lets you do dependency management. So it all sounds really cool. The first caveat is native browser support isn't there yet, although it's progressing very quickly. This is what it looks like natively. So templates is probably the most well supported. Custom elements is lagging a little bit behind, and then Shadow DOM and HTML imports. Mozilla's been very positive on a number of these pieces, and then we're actively working with them on the specs to get these hammered out and implemented. So these web components primitives sound really cool, and it sounds like there's kind of a bigger story that's developing around what you could do with them. How can I tie these primitives together to create something that I, as a developer, it's accessible to me, and I can create interesting things like that select element with. And so that's kind of where the Polymer library comes into the picture. So what Polymer is, it's at its core, a sugaring layer over these HTML import spec. So if you want to use these specs natively, if you want to use the native APIs, it can be cumbersome and complicated. Polymer is opinionated. It says this is how our thinking goes and how you should tie these specs together to be able to create your own powerful elements. So what Polymer is and what Polymer isn't, I'm going to talk about 3 different layers, and I want to be very, very clear about what I mean when I'm talking about Polymer, and then what I mean when I'm talking about other pieces that the Polymer team has also built, but aren't necessarily part of that core Polymer library. So I'm going to talk about the polyfills, which are shims over the web component specs. The Polymer layer, which this is Polymer. This is the sugaring layer, the opinionated library that goes on top of web components to tie them all together. And then I'm going to talk about the components, which the Polymer team has also built using Polymer, but are not part of the core Polymer library. You don't have to use these components if you're using Polymer. So Polymer this is what I mean when I talk about Polymer. It's just the library that provides the sugaring and the opinionated framework or ideas above web components. So the polyfills. I mentioned the polyfill layer, relatively straightforward. I showed this slide before. It made us all sad that not all browsers support web components natively yet. What the polyfills do is they provide these native APIs on top of browsers that don't natively support HTML or web components. So they work pretty well. They've been in development for a while. They're public on the web components GitHub. And they support these specs, so they let libraries like Polymer actually work across modern browsers. So that's an exciting and kind of necessary part to even talk about the rest of this. Polymer.js. This is the Polymer library. It's a lightweight, opinionated sugaring over web components. So instead of trying to kind of deep dive into each individual part of the Polymer library and each API service, I'm going to talk about kind of how Polymer's opinion sugars over web components natively. So I'll go over each of the web component specs and then show how Polymer takes that and lets you build kind of fully featured elements. So the first is custom elements. So vanilla custom elements, if you wanted to just use the web component's raw version of custom elements and you want to create a new custom element, you call document.registerElement, give the name of your element, give it a prototype, and then bam, you can use it on the page. Polymer says, why not make that easier? Why not make it declarative? So we give you this kind of helper element, this Polymer element. You name it what you want, Polymer element name equals paper tabs, and that handles giving it the prototype and actually registering it on the document. And then you can use it in both cases just by using a paper tab on your page, just like you would any natural HTML element. And it appears to script just like any normal native HTML element. The second is templates. So if you want to create a vanilla template, you can just use the template tag, and then you have to fetch it, grab it with script, and stamp it out on the page, and then you have your template actually in the DOM. Polymer says, well, every element should have a template. So every Polymer element expects this template if it's got layout involved in it, and that's where you actually scaffold up your DOM and your layout for the element you're trying to create. So in this case, if I'm trying to create a list of users, I can say, OK, here's my template. Here's my list of users, and here's what it's going to look like, and mark it up. And Polymer actually extends templates. We give kind of nice, powerful behavior on top of templates. So we let you do things like template repeat. So maybe you want to have kind of a repeated list of users. So in this case, we use Polymer's data binding to bind into this template tag and then repeat it, just like a for loop, as actually in the DOM. And we stamp that out for you and make sure that it's efficient. So the third, Shadow DOM. So vanilla Shadow DOM, if you wanted to do it the raw way, you can take an element and create a shadow root, say, hey, this element, I want to create a shadow root on it, and then stick things inside of it, in this case with inner HTML, and then it'll be hidden away and scoped away from the main document. In Polymer, we say every element should have a shadow root. So everything that you put in this template, we should put in a shadow root. And what's really cool about Shadow DOM is not only does it give you this scoping, but it also gives you composition. So within Shadow DOM, you can say there are these content elements. So I can say this is my insertion point. This is where I want all my children of my element used in the main document to actually be laid out on the page, or actually laid out within my element. So in this case, I've got a profile card, which is my element that I just created with Polymer, and I want to give it a title, a header. And then within the actual element code itself, the element markup, I can say, OK, I've got this markup. I've got a card title div. I want to give it a class. And then this right here is where I want to put any header child that I have. So that's what this content select is. That's native Shadow DOM. It's part of the native Shadow DOM spec. Polymer respects all of that and lets you do that. And so this is kind of how you start composing these elements together. And you can imagine that with this, you can really create this select element. All the select element does is say, OK, look for all my options, and then put them in a particular place in my layout. And then finally, HTML imports. There's really no sugaring here. We just expect you to use HTML imports. So the kind of best practice that we're finding is you define your elements in individual files, which makes kind of everything very manageable, and then you just import them directly into the page. And each element can have its own dependency management. So if your element uses another element, which uses another element, those can all import themselves, and you don't have to worry about that as the end user. You just import the element you want, and you get the rest of its dependencies using HTML imports. So Polymer is just this sugaring library. It lets you create new elements in an encapsulated way. But it's not particularly useful until you actually have elements that you've created with it. So the Polymer team has gone ahead and created a number of these elements using the Polymer library. So I showed this slide before. This is the kind of primitives that you get if you're using just the raw DOM that you get normally. Why can't we build this for the mobile web? What if we had things like animated page elements and menu button elements and page scaffold elements? What if we designed HTML for the mobile web? And you finally can do that with web components. So instead of everything having to be a div and then having to overload divs, you can actually create really nice apps out of this. You can create apps with different kinds of icons, different kinds of elements, and it's much more readable code. So we created sets of these elements. We created 2 sets so far of these elements to kind of showcase the things you can build with Polymer. By no means are these the only Polymer elements out there. These have particularly been built by the Polymer team. So the first is core elements. So we discovered there's this kind of set of elements of pieces that developers need to create apps. So we built those kind of core pieces as part of our core element set. And these include both visual elements and non-visual elements. So visual elements are just like you'd expect. They're the toolbars and the drawer panels and the menus, all the kind of primitives that you need to build a modern mobile app or a modern app in general. And then non-visual elements is kind of where it gets funky and cool. What if we could express these things like local storage and AJAX calls and ranges, these kind of ephemeral things that don't necessarily have layout on the page as elements? And so that's a really kind of powerful idea that I'll get to in a little bit. So to go over what these elements look like and how you can use them. So core toolbar is an example of an element that we built in Polymer. Brand new HTML element. If you want to import it, you can HTML import it onto your page, and then you can simply use it. So I can put a core toolbar on my page, put a div in it, which is my title. It knows to put that up at the top, aligned left, and that's it. This is it. Also, all the markup that I need in order to get this layout. But oftentimes, you want to put more than just a title in your toolbar, so you can start composing. So in this case, I've taken a core icon button, this menu icon button, which is another element that we've created in Polymer. And we can compose it with the core toolbar. So I put it in before my title. The core toolbar knows how to lay itself out. It knows to put this menu button to the left of the title and to push the title over, give it some spacing. And again, with this very limited, very readable, totally declarative markup, I get the behavior of this toolbar for free. Really nice way to start building an app. And before, I'd have to put a bunch of styles in here. I'd have to put a bunch of coloring and things like that and make sure that it scales to the full width of the screen. That's all encapsulated within these elements. So don't have to worry about it at all. And then it starts to get really cool, because I can keep composing these elements just like I would normal HTML. So this is an example of a core header panel. So the header panel idea is oftentimes apps, you have a header and you have a body. And you want the header to lay out one way and the body lay out another way. So the core header panel is that. So we have, at the top level, a core header panel. Underneath that, our core toolbar that we created in the previous slide. And that has our icon button and our title. And then below that, we have our kind of content child. So we have our header and toolbar, which is the top piece. And then the second child is the content. And core header panel knows that that's what it expects. It knows to lay those out as I've shown. And the really cool piece then is you get this kind of behavior for free. So you get the body that scrolls underneath and then the header pins. I didn't have to do any scripting to make this happen. I didn't have to kind of wrap around kind of funky things and try to deal with my scroll to get the scroll bar to look correct. This is all baked directly into the core header panel. And this is all the markup I would need. It's all in markup. Didn't have to touch JavaScript once to make this happen. So again, really cool way to lay out pages. And because it's all declarative and these elements can understand kind of custom attributes, I can put a different mode on my core header panel. So in this case, I do mode equals scroll, which again is built into the element itself. And mode equals scroll says, instead of the body scrolling and the header pinning, I want the whole thing to scroll. So this is, I get this behavior, I can scroll the whole thing away. Again, no script, didn't have to change anything in JavaScript. I purely added an attribute to the core header panel, and then it knows how to define its own behavior, how to lay its children out, and to give me this for free. So really, really neat types of things that you can do with elements. Third piece, core drawer panel. So we saw that across all kinds of different apps, we need this responsive layout. So you need lots of apps have a drawer, and then a main kind of body section. And you want that drawer to be responsive. So when you have a small screen, you want it to hide away. And when you have a big screen, you want it to kind of show and be available at all times. So the core drawer panel, again, takes two children. It takes its drawer, which you give it the drawer attribute. And it takes kind of the main body, you give it the main attribute. So the drawer shows up to the left. All the markup that I put in there shows up to the left. Again, in this case, I've composed new elements underneath it. So roadmap, satellite, and then a search box. And then to the right, my main panel. And so in that case, I can put a map, I can put a toolbar, whatever it may be. And this translates perfectly with no additional markup, no additional scripting between mobile and desktop. So it's responsiveness for free. So you get this nice drawer that when you tap this menu button, it'll come out, and you can use the app on mobile, use the app on desktop. You as a developer didn't have to really worry about this. The core drawer panel did this layout for you, gave you responsiveness for free. So you can imagine that these types of layout elements become incredibly useful. You can encapsulate things like grids. You can encapsulate all kinds of different scroll behaviors in elements, and never once have to worry about script. You kind of build it once. If it works, you can use it everywhere. So those are some examples of the core elements. There are a whole bunch more that I can't get into now. We also have a second set of elements. So core, you notice the style was kind of straightforward, meant to be extended, meant to be styled and themed. Paper elements, we said, what if we took all UI widgets, what if we took all the kind of natural widgets and buttons and things that you get on the page, and what if we turned them into material design widgets? So material design was a kind of design philosophy that was laid out at Google I/O last year. And Polymer and the Polymer elements, specifically the paper elements, are the reference implementation for material design on the web. So we took the spec, and we worked directly with kind of the authors of the material design spec to directly, with a high fidelity, perfect fidelity, build these all as elements built with Polymer. So I'll show you what I mean. We have a paper input, which this paper input is kind of, it's your text input. But it gives you this really nice paper animation. It gives you this transition when you click it. It brings this floating header up. It can give you some free kind of validation and error messaging. Again, I didn't have to worry about how this was built. This is a pretty complicated set of animations to do. But I, as the end user developer, don't have to worry about how that was built. I can just use paper input, give it a floating label, give it a validation regex, give it an error message, and I get all this behavior, again, for free. Another example is checkboxes. So checkboxes are super old school. What if we brought checkboxes into the 21st century and designed them with material design? And so that's what the paper checkbox is. Works just like a checkbox, gives you this really pretty animation, which again, I don't want to have to worry about how to get this animation to work. I just want to use it. So if you're trying to build an app with material design, you can use paper checkbox. You get all that behavior. Another one, paper ripple. So material design is rife with these little ripple animations. It's really nice when you're playing with a touch interface and you touch a place and a ripple emanates from your finger. It feels really good. And so ripple, again, is one of these animations that I don't want to have to worry about how to implement that, but I want to use it. And so ripple is actually a composed element. So you can put it inside any element and then trigger it when you need it, and the ripple will kind of ripple out to fit its containing element. So again, really nice animation. I don't have to worry about how it works. I can just drop it in and get that. Shadows are similar. What if you wanted, and in material design, it's specced out exactly the depth of each shadow. But I don't want to have to worry about styling all my elements with very specific shadows. I just want to use this kind of Z number for that, and then I want to get the animation for free. So again, this is a composed element where I can drop a paper shadow in any other element, and it gives me this shadow behavior, again, for free. So this is just a very small sample of many of the material design paper elements that we've created as the Polymer team. But we showcased them in this app called Topeka that we released at I/O last year. And it kind of shows what kind of apps you could build when you put all these paper elements together. And you can play with it. It feels really nice. It's really kind of a novel experience on the mobile web. But it kind of just shows where this feature could be with these sets of elements. And if you look in the code, it's remarkably clean, because it's just all of these elements marked up. It's like you would have normal HTML, but with all these fun new element names. So all these paper elements are on polymerproject.org. You can check them out. We're in the process of building new elements all the time. So you can play with them, see them, play with demos. And it's a lot of fun, and it just feels really great. And finally, where it also starts to get really cool is because these are elements and they're fully encapsulated, you should be able to kind of play with them visually in the same way that it's so easy to write markup with them. So that idea kind of came across our table, and we thought, well, we should be able to build a kind of a WYSIWYG type editor using these elements. And so we built Designer, which is right now a prototype, but there's lots of cool places where this kind of designer idea could go. And this is a true WYSIWYG editor of HTML elements, but it's not like your Dreamweaver. This actually outputs code that is exactly the markup you would use, and it's totally readable and totally nice. Because all the APIs of these elements are declarative and there's attributes, it can surface those to you just as the designer. And then you can play with it, you can nest these, compose them together, and it'll output code that literally you can use directly inside your project. So we use this to build kind of compositions of elements. We use it to build entire apps. It can get you remarkably far away along the app building process, and it's a really, really great prototyping tool, especially for UIs. And prototyping is even too weak of a word. It's really building the UI visually. So it's almost like you would if you're building a native iOS app and you've got your viewer and you're dragging on your components into that. It's exactly like that for the web. So those are the core elements, the paper elements. Everything I've shown so far has been purely visual, and it's been purely kind of layout and UI. So what if we thought we wrap APIs as elements? What if we could take, APIs are a huge part of the web, and elements is kind of a natural way which we interact with pieces of the web. So what if we encapsulated them as elements? So a question that came up was, I want to build an app. I want to add a Google Maps marker, or a marker to a Google Map inside of my app. Right now, it's super hard to do, because you've got to import the scripts that kind of defines Google Maps, and you've got to script out, and you've got to instantiate your map on the page, and then you have to create this new marker object, and then give it the right latitude and longitude, and then stick it in the right map. So it's this kind of awful combination of having to script it and having to mark it up and lay it out. A lot of code for a simple map marker. So we created the Google Map element. So all this is you drop this on your page, and it will render a Google Map for you, which is remarkably nice and straightforward. It encapsulates all this fetching of the Google Maps API code and putting it in the right place. But it's more than that. We can express the Google Map API that in the JavaScript API is defined imperatively. This is an element, so the natural way to express this is declaratively. So what if I wanted to center the map at a latitude and longitude? I should just be able to add attributes, and you can. You can just say, okay, this is the latitude and longitude. When the map loads up, it'll center at that point. Totally straightforward. What if I want to set a zoom level? Well, it's just another attribute. I can set zoom. I can instantiate a Google Map on my page. Even this alone would take tons of JavaScript to get this to happen. And right now, it's just an HTML import and then using the element on your page. And then beyond that, elements are naturally composable. We've talked a lot about how you can compose elements together. They can expect certain types of children. So I said I wanted to add a map marker. Well, why can't I just give it a child that's a map marker? Create a Google Map marker element, give it a latitude and longitude, give it a title, set whether it's draggable, compose it inside of the Google Map where I want it, and there it is. It'll just show up. So this is completely available. This has been built out already as a Polymer element. There's a whole set of these, actually, on the Google Web Components. So a team has built these out. Our wonderful developer relations team has built out a whole bunch of these. So Google APIs, Google Analytics, Google Calendar. There's like a Chromecast video app where you can cast to Chromecast using an element. Just a whole bunch of behavior that is encapsulated as these elements built on Polymer. So again, as the user, I don't have to touch any code. I can just drop it in and use it. So you can start to see coming together the web components vision. So you can get layout elements. You can get APIs as elements. Really, everything can be an element. And anyone can create these elements, and then anyone else can use these elements, and they're incredibly easy to use. So you're seeing a workflow kind of come together, which is on some place in the web, you should be able to find an element. So a couple of these sites already exist and are cropping up. CustomElements.io is one of them. Component Kitchen is another one, where they register a whole bunch of these elements that have been created. I can Bower install them. Bower is the dependency management tool that we're using, command line right now to manage these elements. But you could even just download it and drag it into your folder. I could find the element. When I'm writing my markup, link rel equals import the element onto my page, and then just use it like I would use any other element. So I get my nice core toolbar layout. So to use a kind of strangled metaphor, but I really, really like it, the old web, if you're asked, build tabs, build tab components, the original question that we started with. With the old web, you're given Duplos. It's like, here's a bunch of divs and LIs and ULs, go to town, try it. We need you to build a Star Wars Star Destroyer, and here are a bunch of Duplos, good luck. And so sure, you can paint them colors, and you can kind of put strings attached to them to get them to behave and modulate the way you want. But really, it's super hard. The platform in the past was not built for this. But with web components, you can now extend the platform to create the things that you actually need to build the products that you want. So with Polymer and the elements and web components, it's like asking you to build a Star Wars Millennium Falcon, giving you a box of basic Legos, giving you the actual kit you need to build the Millennium Falcon, and then also with Polymer, giving you a 3D printer to print exactly the Lego that you might need at any particular time. So this is a much better way to play with Legos. Certainly, I wish I had this 3D printer of Legos when I was actually playing with Legos. It would have been pretty cool. So this is the kind of vision that we hope to create. And then the communities, it kind of bootstraps itself. So as more and more people are creating elements and more and more people are reviewing elements, and you've got open source communities around creating these elements and reviewing them and making sure that they're really high quality, and you're composing elements together to create more complicated elements, you can imagine that web development the ease of web development will kind of accelerate. And before, when creating a UI tab alone is really, really complicated, now we're going to be thinking about much higher level things and be able to do much more powerful things as developers. So where are we now? So I said I was product manager of the Polymer Library. I'll tell you a little about the Polymer product itself and where we are on our roadmap. So for the last year and a half, 2 years, we've been in developer preview. So purposefully, developer preview, pre-alpha, very early stages. It's kind of been an experiment. So as the web component specs have been evolving, the library has been evolving to make sure that the specs work and the library works and that you can create something coherent between the two of them. So purposely, we've been kind of backpedaling from a production-ready claim and developer preview, and we've learned a lot through this. So treating it as kind of an experiment and kind of a high school experience of developing this library on brand new technology, we decided to recently give ourselves a report card. So our engineering manager, Matt McNulty, showed this slide at Chrome Dev Summit, and I think it's a very good summation of where we were then. So we gave ourselves an A on ergonomics. It's really great. You can layer these elements and put them together. It's really easy to build an element. The data binding system is totally straightforward, and you can bind things together, and it's incredibly expressive, so you can do all kinds of things that you want. It's really productive. Now, to build an app, instead of having to start at the bottom, you're given this full toolkit of elements with the core and paper elements. So developer productivity is incredibly better. Expressiveness, as I said, you can express all kinds of behavior within these elements. They can take only certain types of children. They can lay themselves out. Also an A. The two issues that we were having and the two kind of things we were bumping up against again and again, and hearing from the community and hearing from developers was, this isn't fast enough, this is too big, and it's too complex. So a really important use case for Polymer and for web components in general is the kind of progressive enhancement, as it were, of the web. It shouldn't be all of a sudden transition to this whole new thing. It should be, OK, I want to drop in maybe one element. I want to drop in one Polymer element to my page. I should be able to do that. The element is just native DOM. It's native HTML. It behaves the same way as you'd expect any element to. So I should just be able to drop it on the page. And when the Polymer library is a huge library that's heavy and complex, I don't want to have to drag that along behind my element and drop it on the page, which is a completely valid complaint and one that we set out specifically to address. So this is the kind of next release of Polymer that we're working on as we speak. So 0.8. Currently, we're at 0.5.3, just got released. And our next release will be, our next major release will be 0.8. So we're purposely making that big jump in number to kind of denote that there are more than the usual number of breaking changes. We've re-architected the internals to be dramatically more efficient and smaller. And it'll be also a big step towards true production readiness. So as I'll show at the end, a lot of apps are already using Polymer in production, but we want to be totally confident with every piece of the API before we claim that it's production ready. So 0.8 is our kind of nod to we're getting really close. So a little bit about what we've done with 0.8 and kind of the effects of it. So we're 5 times faster than 0.5 was. And this is conservative. So we're 5 times faster on Chrome on the native web components APIs. Where we were running over polyfills on browsers like Safari, especially mobile Safari, we're actually even faster than this, up to 8 times faster or so, sometimes even more depending on the app. So this is a conservative estimate of 5 times faster on native web components. And then another big piece is we're 87% smaller. So whereas 0.5 was this kind of relatively large library as far as libraries go, not huge by any means. I think JavaScript libraries have continued to bloat up and bigger and bigger. Now we're tiny. We're like a tiny bit of an image at less than 10K at this point. So really, truly, we want to enable that vision of I want to use one element built with Polymer. I don't want to have to worry about its dependency because I want it to be so small that it's like not even a quarter of a tiny image to drop it onto my page. So that also we're looking to realize in 0.8. And so the ever important roadmap. 0.8 is imminent, as I'm saying. We're working on it actively. We're kind of putting the finishing touches on it. It's actually already public. It's in GitHub, is a branch of the Polymer library. So you can go, you can check it out, you can leave comments and feedback. There's kind of a getting started guide already, but purposely we haven't released it yet because we do want this feedback before we actually drop it, given that there are a larger than normal number of breaking changes. 0.9 we're hoping to get out by Q2, which will be like a true beta, like a true Google beta, and that you can try it and play with it, actually build really cool things with it. And the changes from 0.8 to 0.9 will likely not be nearly as significant as 0.5 to 0.8. And then finally, the 1.0, the production-ready 1.0, we've slated for around mid-year. So exciting parts also, we're not alone. We're not the only team trying to do this with web components. Mozilla Brick has a great team that's building a very similar type of library for kind of wrapping together web component specs, specifically for Firefox OS as kind of their main driver. And they also built elements, sets of brick elements. So they built a brick app bar, a brick deck, brick tab bar, et cetera. And again, the really cool part of web components, because they're baked in natively, and because these libraries are so small, relatively speaking, we can use all kinds of different of these components together. So there's absolutely no reason why you can't use a core icon along with the brick tab bar, which is a core Polymer-based icon versus the brick Mozilla-based icon. An x63 element might be kind of its own raw HTML web component. And these can all work together in peace. There's none of this pick one top-level JavaScript framework from the beginning, and then you're invested for the rest of your company's history. These web components are purposely, they're just primitives. And you can use them with any framework you want. You could use them with Angular framework, because you just poke and prod them like you would any normal element. So they're purposely kind of low-level primitives, but you can scaffold up all kinds of complexity as you will. So not just browser makers. It's not just browser makers that are working on this community and building these elements. So Bootstrap elements. Bootstrap's a really popular UI framework. What about Bootstrap? So someone built a Twitter Bootstrap grid as a Polymer element. So it kind of encapsulates all of the CSS and scaffolding that Twitter Bootstrap grid gives you and builds them out as elements. So you can build out your page using the Bootstrap grid using these new element types. Also, logical composition and logical state management of an app. So someone built an app router. So an app router actually serves as kind of a router as an element that kind of helps you organize state between your apps, lets you change state, lets you type in the URL, get that magic of the URL, and then load a particular state within your app. So again, it's a kind of layer as an element. And so as these kind of application level elements are built up, you can imagine structuring an entire app purely out of elements and not having to really worry about wiring together too much with JavaScript. Pager, similar idea. So a pager is a really popular kind of thing to have on your web page if you've got a whole bunch of content and you need pages. So someone built that as an element, as a pager element. And then Ajax Forms, similarly, you want to do a bunch of form management. You want to be clever about how you send data to the server. Ajax Form as an element gives you a whole bunch of behavior outside of your typical form. So those are community elements. What about full apps being built with Polymer? So polymerproject.org, obviously, is built with Polymer. We use that to build our entire Polymer project app. The chromestatus.com site is built with Polymer. So this is kind of the latest Chrome features coming down the pipeline that shows what the Chrome team's working on in the platform. The designer tool that I mentioned that lets you, is the WYSIWYG editor for pulling out components and scaffolding them, is also itself built out of Polymer. So you can go into designer tool, load in the designer element, and drag it into the designer. And then it's turtles all the way down. And it's pretty neat. And then finally, and most excitingly recently, the Santa tracker that was incredibly popular that Google launched over the holidays, this was built in Polymer and out of Polymer elements. And again, you could go in and look at the code, and they're forthcoming with some walkthroughs and white papers on how they actually did this. So really exciting stuff for a library that is in developer preview, but this was totally productionized, and they had to serve it all around the world in 30 different languages. So a pretty incredible undertaking with the Santa tracker team. And then even just with raw web components, there are some major websites that are using this. So GitHub, which I think we're probably all fans of, GitHub uses a raw custom element in their timestamps. So for all their time indicators on all the commits and things like that, the time is a custom element that they've created, not with Polymer, but it's a raw custom element that does all their time management and behavior. Again, it's a simple thing to translate time based on time zone, but it's actually not that simple. So, and I don't necessarily want to have to worry about that as an application developer, especially when I'm building UIs so quickly. And so the GitHub has used this and created a custom element to do this for them on the client side. So join the revolution. It's a revolution of web components. It's a revolution of these new platform APIs that are changing the kind of conversation from around being, here, take this thing, good luck, to being, hey, why don't we give developers the same tools that the platform level authors have to extend the platform itself and create new things using these primitives. So learn, webcomponents.org is a great resource. This is the kind of centrally shared website that is contributed to by us, by the Mozilla guys, by the teams kind of all around the community, kind of all together works to create content for this site. Polymerproject.org obviously is a great place to learn about the Polymer project. Build. So if you want to start just creating an element, it's very straightforward. Seed element is a great place to start. It's kind of all the bare bones stuff that you need to start building your own element. And hopefully you find it amazingly straightforward and easy. You can start small. You can start by composing a bunch of other existing elements. If your seed element's a GitHub repository. If you're a Yeoman fan, you can use Yeoman and create a scaffolding of an element as well. And then explore. So it's a wide open world for these components. We've seen all kinds of things starting to be created already, and really the sky's the limit when it comes to the types of things you can build as elements using Polymer and using web components. So I really do think that this new conversation, this new way of thinking about the platform as a fundamentally extendable primitive is really powerful. And I think it will usher in a true golden age, again, of web development, where all of a sudden we can create our own HTML the way we want it as developers, and we can share these apps and these components to really hit that J curve of productivity and of really high quality things that we're building. And finally realize that dream of building the web app and make it look really nice, 60 frames per second, smooth, and feel native. So thank you. Any questions?